Welcome, ladies and gentlemen, to a discussion of a summary of the subatomic particles we've reached for an atom. So we left off in class with our group presentations talking about the Bohr model, and today we want to be able to identify where these different particles are and some of the different ways that we can interpret this data for specific elements. So we've identified that the electrons exist outside of the nucleus. Remember, Rutherford confirmed the nucleus. They have a charge of -1 and a relative mass in AMU of 1/1840th that of a proton or a neutron. For us, our purposes, that means we don't have to include them when we calculate the mass because it's so small it wouldn't be part of the significance of the measurement. Protons and neutrons are both found in the nucleus. Protons have the charge of +1, neutrons have the no charge, and the relative mass of each is 1 atomic mass unit. You'll notice that the actual mass is given there in grams, and those scientific notation values are really quite small. So that's why scientists chose the atomic mass unit to make it much easier to work with. So please make sure that you complete your chart in your note sheet. Now, the periodic table that you received in class is going to be your best friend for the rest of this year. Scientists use the periodic table as a tool to report information about individual elements, and its arrangement, like we're going to learn next unit, is based on some of the properties. So it's pretty cool that some of the early developers of the periodic table chose to make it match some of those characteristics to help us understand patterns in the properties of the elements. But at its most basic, the atomic number is going to be the whole number. You will always want to check your key. On our periodic tables, it's going to be on the top. That may not always be the case. That is the number of protons always. The number of protons is what defines an element. If your atom is neutral, that will also equal electrons. Neutral meaning having no charge. Now the other value that you're going to see is going to represent the average atomic mass. You'll notice that it's a decimal. For our purposes, when we're talking about specific elements, if we have no other data to suggest otherwise, we're going to round to the nearest whole number. So in this case, that 79.90, we would round to 80 if we were talking about bromine in order to figure out the number of protons and neutrons. Straight atomic mass for a particular atom is going to be the sum of the protons plus the neutrons. Please note that that is going to be important for your homework worksheet in just a little bit. Atomic mass is equal to the protons plus the neutrons. Because I can't have a part of one of those particles, we will be calculating those in whole numbers. That's why we would have to round the 79.90 to 80 in that case. That would also mean, knowing the protons from the atomic number and the rounded atomic mass, we would be able to calculate the number of neutrons present, 80 minus 35. That means we would have 45 neutrons in this particular atom. So now you will have an opportunity with your practice sheet to use this information to be able to practice using the represented information in the box to determine the characteristics of the atom. Note that in a neutral atom, which all of these will be for this worksheet, the atomic number will equal the protons or the electrons. You will have to fill in the gaps. Now the only thing you should need your handed out periodic table for this would be identifying the symbols or the names of the elements. All of the numerical data you should be able to do from just this worksheet. So just as a reminder, we're going to fill in 1 to 4 in the top left there. So we have our atomic number up on top, our symbol of the element, the name of the element, and the average atomic mass. Your symbol is always going to be one capital letter or one capital and one lowercase letter. What you will then do is use the data that's provided to fill in the gaps. Now, I tried to show all of my work for filling those in. My atomic number is equal to the protons. Your neutrons come from the atomic mass minus the protons. You don't have to show that math, you can just write it in. So I showed you that I took 16 minus 8 to give me 8, but you could just write the final answer of 8. And then because these are all neutral atoms, your electrons will be equal to your protons. So make sure that you finish both sections of this. You will start to notice some pretty easy patterns as you go through, and that one is oxygen. You do not have to capitalize the first letter of the name. Now, we left off with our last team looking at the Bohr model, and one of the best advantages to this model is representing the electrons and their energy levels. So remember we said that Niels Bohr observed that they were always releasing energy in specific amounts. So he hypothesized that that meant they existed in these particular energy levels. So when you look at the way the model is set up, you'll notice that with the nucleus in the middle, you'll see that there's those 2 electrons that are closer to the nucleus, and then the other 5 that are represented are further away. So that distance is because the greater amount of energy allows them to exist further from the nucleus. So those electrons that are further away are in a higher energy level. Now, when we work with explanations of why atoms behave the way they do in terms of energy, we are often going to be talking about how the electrons are moving around these energy levels. A Bohr model drawing is a really easy way to represent that. I would like you to put this drawing in the right-hand column on the front page of your notes underneath the part where there's the bromine box. So please draw the nucleus, the 3 energy levels, and label what energy level they are and how many electrons can fit there. There's going to be a little weirdness with that 3rd level, but that's okay. We'll explain it on the next slide. Now, if you turn your page over, it looks like that we can only work up to atomic number 20. And largely that's because for our purposes and what we're able to study with the Bohr model, we can only work up to about 18 total electrons. And some properties of atomic number 20 and 19 will work within that. So on your last page, you'll notice that the 3rd energy level said it could hold 18 electrons. But for the Bohr models we are going to draw, the most we are going to put in is 8 in the 3rd energy level. And that's because larger than 20 electrons kind of starts getting into these more complex models, and that's why Bohr is not our current model. But he was very, very close. When we draw Bohr models, we will always start in the middle, closest to the nucleus, and then we fill further out from there. So I put 2 on the 1st energy level or ring, then I can fit up to 8 in the next, and then on the next one I can fit up to 8 as well. So if you look at your Addams Family Math diagram, or worksheet, and flip it over, there's a section for us to practice Bohr models. And we are going to use the information from the atomic data that's presented in the top part of each box. You'll notice that there's a key for the symbolic notation. You'll use the symbol of the element. The number on top is going to be equal to your atomic mass, and your number on bottom is equal to your atomic number. Now for any neutral atom, that's the part we care about because that's what's going to tell us how many electrons we need to draw in. So I'm going to start with my symbol in the middle, and then I'm going to start placing electrons from the first energy level out. Now, the first energy level can hold 2 electrons, so I drew 2 dots to represent them, but I still need to place one more, which means I'm going to need to draw the next energy level. I then place my third electron on that energy level. So pretty much all you have to do is identify how many electrons you need to place. Same as the atomic number in a neutral atom. Then I draw my middle nucleus with the symbol. I draw my first energy level and place up to 2 dots. Then I continue on placing electrons till all of them have been placed, up to 8 in the third energy level. So your homework is to complete the rest of your practice sheet for atomic family math, as well as the Bohr models and the magic square activity. Should you do them all correctly, all of your totals for the rows and columns should equal the same number. Please let me know if you have questions.